after the outlier we have 702 elements. As we seen the earlier, our original data set consists of 918 records, but after the outliers removal we have a unique values of 702 records. So now what we have to do, we have to move these outlier removal data to our original data frame. So after run that, our data are moved to our data frame. So now what we have to do, we have to do label encoding. So label encoding means, we have seen that in our data set there are numerical values and we have character values, that is string values. Let me show you. Here we have a general information of our data. So look at here, in our data we have gender as male and female, and like we have chest pain type ATA, NAP, etc. And also we have resting ECG, that is normal, ST, like that, and exercise agina also, and ST slope. So we have a combination of numerical attributes as well as character attributes. So for displaying graphs, what we have to do is we have to encode our data in the form of character into numerical values. For example, in gender we may have male and female category. So here I have assumed that the male category as 1 and the female category as 0. Likewise, we have decided for all the character attributes with the help of 1, 2, 3, 4 values. So once after done all the label encoding, so now all the labels are encoded. Now let me check the str data. So look at now in the console window, there is no character data type, all are integer and numerical data types. So this is easy to fetch with the feature selection. So if the data are in the combination of characters and integers, we can't able to go for feature selection. So what we did all the numerical, all the characteral and string data into the numerical data. Now we are moving to the feature selection. So in feature selection, we have to select the features in the way of splitting our data. So while splitting our data, how we split our data? So while before splitting, we have to train a model and we have to test our attribute. So I have taken a split ratio as 0.7, that is 70%. So here our training set consists of 70% of data and test set consists of remaining 30% of data. Let me run this. So now we'll check the train set. Look at here. So out of that 700 data set, around 490 is our 70% of training set, and the remaining 200 something are from our test set. So after done with the feature selection, we have to go for data transformation. So why do we need to data transformation? This data transformation is enlarge our data to improve the quality. So the data's quality is improved, and also the goal of this data transformation is to improve the quality, structure and usefulness of the data. So after train, we'll look at the head value. So here I have the head value. So here this scaling element, what this did is, here it will provide the values in the floating value. So it is elaborated, that is enlarged the data, and it will produce the floating data for the detailed output prediction. So the next one, after data transformation, we have data exploration. In data exploration, we have different categories like univariate, multivariate and bivariate. So based on the data, we can explore and we can visualize it. So for example, I have taken the age, resting BP, cholesterol, max HR and old peak. All these are continuous values. Since it is a continuous value, I have used the histogram here. So let me run the histogram. So this is a histogram. So this histogram is for the final element of old peak. if we export this graph as image, we have